Hello and welcome to Audiophile. I'm Rick Schultz.
I'm Aaron Schultz.
I'm Peter Isrealson.
And we're here today to talk a little bit about some tech talk. So Peter is one of the main techs at the shop. He's responsible for putting together any of the electronics that we do. So
how does that feel, Peter, being responsible for it?
It feels great.
Okay, good. Makes
I
me
enjoy
shudder
it.
a little.
So what's your favorite thing to work on that we do? We've had a lot of different projects, of
Yeah,
course.
that's what's fun, having many different projects to work on. It's not
Right.
just one. So
Yeah.
No.
Yeah, recently you did an esoteric piece for one of our customers in
I don't know.
part of Texas. William?
Oh,
in
from
San
Austin.
Antonio or
Yeah.
Austin, Texas, yeah.
Yeah, that was really beautiful. It
Yeah.
turned out really well. It was an esoteric
K1,
K1. Yeah,
Grandioso.
yeah. And what did you do to that bad boy? You did quite a bit of stuff,
Yeah,
right?
most everything in the power supply and
Okay.
voltage regulators and different output stage.
Okay, so you have made some unbelievable pieces for me. Like I've had some really nice equipment, and every time that I believe that I've got top line stuff, I hand it to you. You work on it for a couple of weeks, hand it back to me, and it's just a world of difference. And I know one of the things that you have done a lot of is work on voltage regulators. And can you tell me just a little bit about why that's a go-to thing, and what happens that manufacturers don't actually put in really good voltage regulators? Do you have any idea?
It's cost prohibitive. A really good, well-designed, discrete voltage regulator. It takes effort, and combining the different noise suppression and voltage regulation at the same time is not always so easy.
Yeah.
So some regulators work good in one area, maybe not in another area.
Okay.
So is trying it, is that how you, where does your information come from? Is it like just trying things, putting different things
it's really
in?
trying out different
Yeah.
things. One might work good in one circuit, a digital circuit, but might not work so well in an analog, so you use a different principle there.
I always think it's actually an extra gene that you guys have, because I don't have that. I don't know how to do that stuff or to even pursue it, but I listen to you guys and okay, whatever.
Yeah.
Extra gene.
You're just mad.
Yeah, okay.
Mad scientist.
Oh yeah, crazy a little bit.
Yeah, I noticed like you seem to just know what part to put in, and that amazes me. I was really big on the TX 2575 resistor, and we were using them in our amplifiers, which we still do a lot. Really nice, clean, beautiful resistors. But that's not always the go-to for you.
It is one of the best ones out there, but it doesn't suit every situation, every position in a circuit.
So where would be an example where you wouldn't want to use it and you'd use something different?
Say maybe in a DAC where it's a really great resistor, but say for current to voltage conversion, it doesn't work as good for that purpose for whatever reason. Really don't know why.
Okay.
Just
Cool.
experiences trying things out.
Mm.
So it's not always the best resistor to go to.
Okay.
So we get used to try different ones.
So when you're doing this stuff, you're pretty methodical with, putting together, trying a particular part in a particular place and swapping it out with another one and seeing which one sounds better. Actually,
Yeah, exactly.
so your go-to is to actually put your ears on everything you do.
Yeah, it's not always measurements. We use measurements, but it doesn't really tell you what the end result will be. So you
Right on.
gotta listen.
Cool. So that must take a powerful amount of time to go through everything
It
so
does.
methodically like
Yeah.
that.
It's tedious work.
Yeah, no doubt.
What about the application of magnetic conduction technology? What you do for us in the amps that we do, that you've been working on?
It's always been an improvement. Putting it into what we're doing now is putting into the circuits itself, amplifier circuits, CD player circuits, and it's always been beneficial. We always just have to pay attention to the polarity of the magnet, where the right polarity gives it the correct benefit.
Yeah.
Which
It's been a lot of fun. I mean, when we started applying them to the transistors, I mean, it was just shocking to me.
Yeah.
what we got out of that.
Right.
That was lots of fun.
Yeah. So that's a whole new avenue. We just opened up doing that.
Yeah. Yeah, that's been neat. And then you, of course, then took that a little bit further and started applying basically what our patent talks about, and actually mounting transistors with the actual magnetic devices that we use.
Yes.
Yeah, and that was on a bipolar input transistor, if I remember
Yes.
correctly.
Correct.
Okay.
Yes.
So basically, there's two stages of amplification in the MA70, which is our 70-watt version amplifier with the big chassis.
Yes.
Okay, and so both of those are treated then.
Yes.
Yeah, that's cool. We've done a lot of neat stuff in the power supply, and I know one of the things that you've done is develop your own infinite capacitor. So can you tell us a little bit about that?
Yeah, capacitance multiplier. It's what we found out to be that when it comes to reducing noise, it's one of the best circuits to do that.
Okay. And there's other products on the market that are similar to that. I know that Jack Bybee, for example, made a
Capacitance multiplier.
right. Thank you very much.
Just
It's
like that.
very good. Yeah. But you decided to take it upon yourself to design your own.
Yeah, just take it a little bit further.
Right. It's never good enough for Peter.
Yeah.
I like that about him.
It's a theme. We gotta get a T-shirt made for you. How far did you say?
Yeah.
As far as we can.
Yeah.
And so other features now. Recently, I've had you add the voltage regulator into. I just like the idea also of taking it as far as we possibly can. And I know that we've got the both the capacitance multiplier on our power supply. We've got a regular filtering system that was designed by Steve Kaiser himself. And from that one, Steve has told me, is to try to dissipate the amount of resonance inside the transformer itself, because transformers make a lot of noise.
Yes, and you get a reactive load, so you have to tame that, calm it down, so to speak.
Okay, and what's a reactive load?
Well, you have a transformer, bridge rectifier, and the capacitors, and those three will interact with each other. It's sort of like the charging pulse, a 60 hertz cycle that charges capacitors, causes a pulse, and it reacts back through the diode, and then it reflects back into the transformer. So that's what you want to try to tame, that reactance of that resonance that occurs in the transformer.
Okay, so you're not only getting problems with the whole idea of it being an inductive design, where you've got these spiraling magnetic powers that are working against one another, causing just incredible amounts of resonation and vibration. But you've got a whole different problem based on what's happening with the capacitors and the rectifier feeding back into the transformer.
Correct.
So is that mechanically based as well, or?
It's electrical and mechanical.
Okay.
The end result is mechanical, but then it's electrical resonance.
Right. And we do a lot with the transformer itself as far as trying to tame resonances on the transformer mechanically as well.
Yes.
And also trying to make sure that the transformer isn't bleeding out any electromagnetic interference of any type.
Right. Correct.
Yeah.
Disturb anything else. Yeah.
Right. And within the MA70, which is a design, it's a very unique amplifier. It's something that it's, I guess, one of our pride and joys at the shop, right?
Yes.
And something that we have a lot of love for, I guess. We built a chassis around that is really unique, kind of modeled loosely around what Bob over at Star Sound has done with audio point technology. Where we actually even flex the circuit board to give it a bit of stress, so that the mechanical dampening technology that we use will channel everything out through into the points that we've got on the bottom. So the whole thing is kind of a calculated pathway, not so indifferent from what Robert does with his racking technology.
Yes, that's very accurate.
Yeah. So it's fun to put together right here.
Yeah.
One of the reasons for that is because the amplifier is actually built out of tolerance. And there's a lot of design that goes into this amplifier. And it's one of the reasons why it's so expensive is We have tried to think every part of this through as far as we can. And so one of the things that we are doing, for example, is when you buy a lot of electronics, you're not going to get those top end regulators. We use top end components throughout the amplifier.
Yes.
Yeah, and on that, you handpick and select every part for every or every portion of the board.
Yes, indeed do.
Yeah, that's cool. So that's one of the reasons I can tell you that it sounds so good. Steve has done just an amazing job with this new circuit. Peter does an amazing job with the parts and the assembly, and we throw everything at it, including is there a kitchen sink in there?
Yeah, I think we managed to fit one in there.
It's big enough.
It is big enough. You could use it as a kitchen sink, I guess, because it's got the volume. Yeah.
Doing dishes the way you do, I'm sure you're good.
So it's a blessing to have Peter here. We're going to do a couple more videos while we've got him around. So if you get a chance to come back and chat with us through the comments below, if you want to ask Peter a question, please go ahead. And for now, we'll just say that we're going to have an end to this episode, and we thank you so much for following us.
Thank you.
Thank you.
Bye-bye.